I welcome all of you to SS2 Mathematics, and the topic for this week is called bearing and distance. Now, under bearing and distance, you need to be familiar with the directions given in any question. That is how I would like to start with. You need to be familiar with the directions of a compass, or I call it, you need to be familiar with the cardinal points of a compass, familiar with the directions. That's why I'm starting with this particular image. You need to be familiar that going up here is the north, coming down is the south, to your right you have the east, and to your left you have the west. Now, in between the north and the east is called the northeast, and in between the south and the east is called the southeast. Also, in between the south and the west is called the southwest, and in between the north and the west is called the northwest. Now, there are four main directions of a compass. The four main directions are the north, east, south, and west. Now, these four main directional keys are supplemented by 8 secondary intercardinal points. They are supplemented, that means they are assisted by 8 secondary intercardinal points. And these 8 secondary intercardinal points include the northeast, like I said, the southeast, the southwest, and the northwest. Now, let me move away from this. In bearing and distance, you will be given the locations on how to start. If they say a boy walks 40° northeast, it is left to you to know the particular area where northeast is. You know that northeast is speaking about this area. You can say a car was moving northwest. This is northwest. So that's why I'm starting with these cardinal directions. Going further, I remember last week I taught you something about the first quadrant, the second quadrant, the third quadrant, and then the fourth quadrant. That's why in every video that I teach you, I take my time to explain it. Now, the first quadrant is talking about the 90° section. The 90° section is between the north and the east. The second quadrant is between the south and the east, which is the 180° second quadrant. The third quadrant is between the south and the west, which is between 180 to 270°. And then the last and fourth quadrant is between the north and the west, which completes it 360°. Now, hope it is clearly understood. Now, there's one other thing you need to know. If you are given a question that a particular ship travels 40° northeast, if you are given a question that a boat travels 40° northeast, looking at this first, second, third, and fourth quadrant, you know that northeast is in this region, this section, and then you are looking at 40°. 40°, as I told you, is from 0 to 90. So therefore, it is traveling this section. Did you see that? If you're also given a question that a boy walked 10 kilometers 50 degrees southwest, 50 degree, 10 kilometers 50 degrees southwest, what comes to your mind? Where is southwest? It is not a must that you have to seek for 50 degree. You will say, okay, since Mr. Williams says that 0 to 90 starts from north to east, therefore 50 degrees should be in this section. No. Also check the notations, the bearing. This particular one says southwest. So where is southwest? Southwest is in this region. Have you seen that? Now there's something you need to know. The notations for bearing, we always start with north and south. The notations for bearing, we never start with east or west. What am I trying to say? What am I trying to say here? What I'm trying to say here is the notations for each bearings, we never start with east or west. You can never have something like 50 degree east north. No, it is wrong. The notation is never correct. It is 50 degree north east. That is the correct notation for bearing. Also, notations for bearing can never start with west. So you can never have something like 49 degree west south. No. It will always be 49 degree south west. Therefore, the notations for bearing must always start with north or south and end with east or west. That means you can either start with north and end with east, or you start with north and end with west, or you start with south and end with east, or you start with south and end with west. It will always start with north or south and end with east or west. Now, you need to be very, very careful when it comes to bearing. So let's go to question 1 and quickly solve the question. But before we go to question 1, let me just remind you of the formula for finding distance and angles using sine rule and cosine rule. You know, last week I told you that the formula for sine rule is the small letter a over sine A equal to small letter b over sine B equal to small letter c over sine C. Remember, you can't use the 3 at once. It's either you use a over sine A equal to b over sine B and find 1. Either you find a or you find b. Or you can use b over sine B equal to c over sine C. You pick 2. You can't use the 3 at once. You either choose 2 out of 3. I can choose a and c and ignore b. Or I can choose b and c and ignore a. That is the formula for sine rule. And the formula for cosine rule, looking for the distance of either a, b or c. Using cosine rule, I said a square equal to b square plus c square minus 2bc cos a. Please, you need to be conversant with this formula. If you are looking for b, the side b, the distance of b, you use b square equal to, what are you giving? A square plus c square minus 2, pick this 2, ac cos, what are you looking for? B. If you are looking for small c, it will be c square equal to a square plus b square minus 2ab cos, what are you looking for here? C. Please be conversant with these formulas. Quickly, let's go and solve question 1. Question 1 says a tree is on a bearing of 36 degrees southwest from a point X and 78 degrees southeast from a point Y. If X is 200 meters due east of Y, calculate the distance of the tree from Y to the nearest meter. You can see the question they are giving you, southwest. I told you can never start with west and you can never start with east. Your notations for bearing will always start with either north or south. So you can see southwest. So it depends on you to know exactly where to draw it. So this 36 degree will be in between south and west, and this also one will be in between south and east. So therefore, let us sketch it. They said a tree is on a bearing of 36 degrees southwest. A tree. So let us assume this particular directions is my tree. My T, known as tree, is on a bearing of 36 degrees southwest. I have north, I have east, I have south, I have west. That means it is going to be here. (36 degrees southwest). You can see that. You see the way I'm doing it. Then the second one, it says that same tree is on a bearing of 78 degrees southeast. The same tree is on a bearing of 78 degrees southeast. So therefore, I'm having southeast on a bearing of 78 degrees. The first one says it was on a bearing of 36 degrees southwest from a point X. Then the other one says that same tree is 78 degrees southeast from a point Y. Now they now said if X, this particular first one we drew, is 200 meters due east of Y. If this X is 200 meters due east, remember this particular right hand side is east. It's 200 meters due east. 200 meters due east of Y, this Y. Calculate the distance of the tree, which is this T, from Y. Calculate the distance of this tree from Y. That means we are asked to calculate this particular area, this particular distance. Now, if I am to add 36 plus 78, what do I have? I have 114 degree. The combination of the 36 degree and the 78 degree to give me 114 degree. Now it is not done. It is not yet over. Now we need to get this particular angle and this particular angle. It is very, very simple. But before we get that angle, let me show you one or two things. Now, if the bearing of X from Y is 50 degrees southwest, so let me start from here. Since they are saying southwest, it is an example, it is not in your notes. If the bearing of X from Y is 50 degree southwest. That means I'm having a connection. It's 50 degrees southwest. 50 degrees southwest. Now calculate the bearing of y from x. Calculate the bearing of y from x. If this particular point is 50 degree, the remaining part is what? 40 degree. Because we know that a quarter of a quadrant is 90 degree. That means this particular place here is 1/4 of sum of angles at a point. So 1/4 of sum of angles at a point is 90 degree. So if here is 50 degree, here is 40 degree. Therefore, if here is 40 degree, this particular place is 40 degree. And if here is 50 degree, this particular place is also 50 degree. Why? It has a rule in mathematics. What rule is that? Because that particular rule says alternate angles are equal. So therefore, if this particular angle here is 50 degree, it is alternate to this particular place, which is also 50 degree. Let me give you another example for more clarification. If here is 50 degree, what is this particular angle? This particular angle is also 50 degree. That is what I'm trying to say. Alternate angles are equal. So now, going back to that question, if this particular point, the first bearing they gave us, the first notation they gave us, 36 degrees southwest. If this place is 36 degree, complete the remaining part of that quadrant in southwest. 36 degree, take 36 degree out of 90 degree to complete the remaining parts of the quadrant. So what is 90 minus 36? 90 minus 36 will give me 54. So to complete this particular half of the quadrant, it will give me 54 degree. And we know that if this particular remaining part of the quadrant is 54 degree, alternate angle is also 54 degree. That's why you have 54 degree in your notes. Now, if this particular second notation they gave us, which says southeast is 78 degree, complete the quadrant. To complete the quadrant, 90 minus 78 will give me 12 degree. So if this particular outside region is 12 degree, alternate angle, it is alternate. So alternate angle, this particular area will also be what? 12 degree. That is why you can see that particular diagram in your notes. Here is given as 114 degree. This particular area is given as 54 degree, and this particular area is given as 12 degree, because we calculated this remaining part of the quadrant to be 54 and brought it here, calculated this remaining part of the quadrant to be 12 and also brought it here. But that's not the question. The question says calculate the distance of the tree from y. That means we have to calculate this particular area. Therefore, to calculate that particular area, the distance of the tree t from y, we can use the sine rule, which is looking for the distance a. I'll just say a over sine a equal to b over sine b equal to c over sine c. Now a here I don't know. A equal to, what is the angle opposite a? 54 degree, which is sine 54 degree, equal to, I can see that this particular one is complete, so I'll just pick sine, which I'll pick b, which is 200 meters, 200 meters over sine B, which is sine 114 degree. So I can go ahead by cross multiplying. I will have sine 114 degree times A equal to 200 meters times sine 54 degree. Have you seen that? So therefore I divide both sides by sine 114 degree. Sine 114 degree cancels sine 114 degree. So what am I left with? I am left with A equal to 200 meters times sine 54 degree equal to all over sine 114 degree. Now to solve this particular question, we have to make use of the logarithm table. Remember last week when I was solving sine rule, a question on sine rule, using sine rule, I made use of logarithm table. So to continue this particular question, to get A, we have to make use of the sine rule. So we make use of the logarithm table. Therefore, to make use of the logarithm table, remember the question is saying 200 meters times sine 54 degree divided by sine 114 degree. So we start with the first one, 200 meters. The first number here is 200 multiplied by sine 54. Using log and using indices rule, multiplication turns to addition and division turns to what? Subtraction. So you have to apply the law of indices in this case. So 200 times sine 54 will turn to 200 meters plus sine 54. So we have to get 200 meters first, and then later when we get 200 meters, we bring the logarithm answer for 200 meters here, bring the logarithm answer for sine 54 here, we add it. Remember, it is 200 times sine 54, but for indices rule it says plus. Then they said divided by sine 114 degree. So that divide will turn to minus. So now let us get the logarithm number for 200. Now, if you go to the back of your textbook, because to solve this question you need log table, the logarithm table. Go to the back of your textbook, it is there in page 241. You will see logarithm of numbers, page 241. You will see logarithm of numbers. Now you can see that logarithm of numbers does not reach 100, talk less of 200, and we are looking for the number log 200. At the back of your textbook it stopped at 99. Therefore, once it passes 99, I'm saying this again, listen carefully. Once a number, you are looking for the log of that number, passes 99, it becomes 2 points. So for instance, for example, if this particular number here is 130, it has passed 99, it turns to 2 points. If this number here is 500, if the number there is 540, as far as that number has passed 99, it becomes 2 points. Please do not forget. Now, once it passes 99, it becomes 2 points. So now how do you now look for the number in the logarithm of numbers? Simply divide that particular number by 10. I repeat, simply divide that particular number by 10. So if you divide this particular number by 10, what do you get? 20. I repeat, once a number passes 99, it becomes 2 points. Then what do you do next? Divide the number by 10. So if I divide 200 by 10, it becomes 20.0. True or false? True. Now you go and look for the 20.0 under the logarithm of numbers. The logarithm of numbers for 20.0 is 3010. Also, you go to the back of your textbook. Also, go and look for logarithm of sine rules, because we are looking for the log of sine. So look for the logarithm of sine rule for logarithm of sine rule 54. You can find that in page, they did not even write page in this your textbook, page 247. You see logarithm of sine rules. Look for sine 54. Sine 54 is minus 1.9080. So you add, let us add 0 plus 0, 0, 1 plus 8, 9, 0 plus 0, 0, 3 plus 9, that is 12. So you write 2 and then you carry 1. 1 plus 2, 3. 3 plus minus 1 will give me 2. Have you seen that? So now let's look for sine 114 degree. To look for sine 114 degree, if you go back to your textbook, go to logarithm of sine rule, you will see that there is no 114. I repeat, there is no 114 because it has exceeded the first quadrant. I wish people usually read your notes. Please always read your notes so that it will help the teachers to always explain in a way you will understand. Now there's no sine 114 because it has exceeded 90 degree. So therefore you remove this 114 from 180 degree. When you say 114 from 180, that means you say 180 degree minus 114 degree. You have what I call 66 degree. So in place of sine 114, we look for sine 66 degree in place of 114. So what is sine 66 degree at the back of the textbook? It is minus 1.9607. So then we subtract 0 minus 7, impossible. We borrow 1 from 9, becomes 10. 10 minus 7, 3. Yes, 8. 8 minus 0, this. 0 minus 6, impossible. We borrow 1, becomes 10. 10 minus 6, 4. Don't forget that you borrowed 1. So this particular area is 1. So we borrow 1 from these 2. So when we borrow 1 from 2, we bring it here. It becomes 11. 11 minus 9, 2. Point. Now, remember you borrowed 1. Oh. So here is 1. 1 minus minus 1. Quickly do the mathematics. 1 minus minus 1 is 1 plus 1. And 1 plus 1 is 2. Now that you've gotten that, we now have to convert it back to number. It is in log form. You have to convert it back to the number. Convert it back to number, please. Now to convert 2.2483 back to number. Remember I said last time that a number that has exceeded 100, you write 2. True or false? So that means if that number now is 2, it means that it is more than 100. So we leave that. Go and look for 0.2483. Yes, go to the back of your textbook and search among logarithm of numbers. Search for 2483 in logarithm of numbers. Please ignore these 2. Why are we ignoring these 2 is because I told you that anything that exceeds 100, you make it 2. So we will deal with these 2 later. We are trying to convert log back to number. So go and look for 2483 in the logarithm of numbers at the back of your textbook. Now what you see there is 2480, not 2483. You see 2480. Now when you see 2480, 2480 is what? It's 17.7. 2480 is 17 under 7. But we want to make it 2483. So therefore, we look for the difference. Go to your textbook again. Go to your textbook. In fact, let me show you your textbook so that you understand. This is 2480. It is under 17 under 7. So I can make it look like 2483 by adding a little bit difference of 1. So this difference of 1 brings it up to 2. So if I add this 2 to 2480, I get 2482. It's close to it. So the answer is 17.71. 17.71. That means I can find it under 17, under 7, difference 1. Now this is where these 2 come in to play. This 2 means that it is more than 100. And I told you before earlier, if you can remember, I said if something is more than 100, you divide it by 10. Didn't I say something like that? Now, since we are not dividing it by 10, we want to now add back these 2. This 17.71 is this 2483. What happened to these 2? We have to multiply this number by 10, which will give us 7.1. That's why you can see it in your notes. It is 177.1. So you see that example 2. Try that example 2 on your own. Sit down quietly, read the notes, look at the way I solve it. This time around, I'm not going to help you because this video has taken too much time trying to explain it step by step. The second example, please practice it on your own. It's very easy. It is just for you to know where the bearing starts from and then where the bearing is going to, either to find the distance or to find the angle, either to use sine rule or to use cosine rule. Study example 2 and also study this example again. And then if you have questions, you know where to meet me and ask questions.